Hello everyone. The problem's name is house robber, and this problem states that there is a thief. He wants to steal from some houses, but the key is he won't steal from the adjacent houses. And there is a term called capability. Capability is the maximum amount he will steal with respect to a house. If he steals two houses, the maximum amount he will steal from the two houses, the maximum of the amounts of the two houses would be his capability. If k equals to 2, it means that he will at least, he will minimum stole from two houses. So if you check here, 2359, it is evident that from 2359, he can steal 2 and then 5. He can steal 2, 9. The minimum of 2 5, the maximum of 2 5 would be 5, which is added to the capability set. Next 2 9, the capability would be 9. And again, we can take 3 9, the maximum capability would be 9. The minimum of the capability set, which is 599, is 5, and this 5 would be returned as per requested in the question. So, in order to solve this question efficiently, we're going to use the approach called binary search here. This question basically leads its roots into dynamic programming. If you see it here, you can see that this question is a question of dynamic programming. Using dynamic programming, see, this is a question which uses dynamic programming. But I'm pretty much inexperienced in dynamic programming, so I'm just learning this. And he says that in order to, he actually mentioned a pattern here. Problems require minimizing the maximum, or maximizing the minimum, often suggest a binary search approach. So in dynamic programming, if we figure out this pattern, we definitely need to use binary search approach. And this is the key takeaway that I got from this problem and yesterday's lead code question also. So what I'm gonna do is I just gonna understand how binary search is working on this problem, and I'm just going to run this code, which I have taken from here. So initially what happens is we'll be checking, instead of focusing on the maximizing a total sum, we need to guarantee that the maximum amount stolen from any robbed house is as small as possible while still robbing at least k houses. A brute force approach would involve checking every possible way to rob K houses while obeying the adjacency constraint. But this would be too slow for large inputs. A more efficient way to approach this problem is to recognize that we are trying to minimize the maximum stolen amount while ensuring that at least K houses are robbed. So, this naturally leads us to use binary search on the maximum reward that the robber can steal from any single house. We definitely define the search space based on the possible values for maximum reward. So how did he define the search space? He defined the search space based on the possible values for this maximum reward. The smallest possible value is minimum of the nums value. The minimum amount he can get from a house. That would be the least value boundary, the lowest value, and the largest possible value would be the maximum of the nums value. So it is evident from this. And then this gives us a range where min reward equals to minimum of nouns and more specifically 1. We use binary search to determine the minimum possible capability that still allows robbing at least k houses. At each step, while we take the middle value in our range and check whether it's possible to rob at least k houses while ensuring that no single robbed house has a value greater than the mid reward. So by this way, we use binary search in order to clarify this way. Let's submit this question. So that's it guys. Today's question is, if you like this video, please subscribe. Thanks a lot.